let me continue here. So here for the node is if we choose the option 2, that means we place the origin at the centers of the orbit. Okay, then we see so this is the center of the orbit, and this is one focus. And this is another focus. So say, imagine this is the elliptic orbit of a satellite respect to the Earth. So say Earth is here. So here, before we use the name, is called the main focus, or simply is called the occupied, because that is a focus about which all the attractions being applied. And this one, basically with respect to this one, is not used. So here, the more specific is we call the vacuum, the vacant focus, which means it's not used in our equation of the orbits. Okay. So with this is in mind, and then the distance here is EA, which is equal to C. We've seen that before and quick in the quick introduction there. So for the main focus, let me call this F. This is called the F star. Okay, so here we say any point A, and that has the let me not to okay, X prime, Y prime, X prime, Y. Okay. To do this one, so if you don't feel bothered, we can just drop the prime. You know what we're saying. We are in the option 2, okay? So not to cause any kind of bothersome kind of the notation, we simply drop prime. So from this moment on. So here again, PF, not PF, AF. We're going to calculate the distance. Okay, from this, basically I'm going to calculate is this distance and that distance. Okay, I'm going to calculate the two distances. So AF will be equal to square and easier, so X minus EA is EA. So this is X, and so here this distance basically, if you take these triangles and simply is the square of the two sides and take the square root, whatever. Okay, so that one equal to, this one is X minus EA squared plus Y squared. AF the same if you take the larger triangles, and that is X plus EA. So here again, I have dropped the bothersome prime in my calculations. Okay, so simply I don't have to count. So hopefully you know we are taking the option 2 here. So from here, and you can see here, this is a square. Okay, nothing special here. I just compare the relations. Get the relation, basic relation can be like this. Okay. So now because we are using the second option, I use this one. Oh my goodness. think it's better we just keep it. How about that? Okay, because here I'm going to use equation 3. So here we use equation 3. df af equal to r equal to a minus ex prime. From this one, r is the distance here. Okay, that is r. So basically, we simply adopt the equation 3 and write it up here. So here we have this information. So therefore, AF Okay, with this one, then let me quickly use 5 minutes to get the important properties. Otherwise, next time I will rewrite everything. So from here, the AF square is equal to A plus ex prime square. This is prime here because we're still using prime, okay, for that. Okay. So here we have two possibilities, and AF start can be this one, or AF star equal to minus A plus ex prime. AF, what is AF star? This is the distance here. Right now, we're concerned is this distance. This distance is always positive. From this expression, we have two possible expressions. And remember, AF is always positive because that is the distance. So this one must be positive, and this one must be positive in either expression. For this case, we pretty much say the A we have to make sure A is positive. Okay. For this one, to put the whole story short, and this one A must be negative. Otherwise, it won't be so possible to have the expression here. Okay. So now for this expression here, so from this expression, let me do this one. So in this way, also we have do these things P start plus so with the first options, we simply do this algebra, and then we can find that's equal to 2A. Because here already PF equal to this distance there. Not P, is A, sorry. Okay, so this is R, AF equal to R minus R equal to A minus EX. Okay, so that's equation 3. So here we have AF. So here we do the manipulation is this one. And from the second options, we do the manipulation is this one. AF start minus AF. Again, that is constant minus 2. So again, from this quick analysis, we have two possibilities. If we take the option 1 as the expressions, then we found this is the quantity. And that means the distance to the major focus, to the foci is constant. This one saying when we go to this option, then the difference between the to the vacant to the major, that is constant. So actually this one leading to here is leading to is E is greater than, this is for electric. and this one is for hyperbola. Okay. And this is the first, the focus directrix property, and this is the second one. So this one gives us the foundation. So next time I will base upon that one and also the two things, and we're going to review the three conic sections: ellipse, parabola, and hyperbola. And in particular here, I want to give a head up because I don't want to redraw everything next time. You can see this is the distance, this is the distance. The distance minus, and that one, actually this is a longer distance, this is a shorter distance from our graphics, apparently. So from here, this is in a way, once we go to talk about the hyperbola, you have to remind A is negative value. Otherwise, the whole thing won't be graphically valid. Okay. So that reason, once you go to the textbook, I have a note. I believe in textbook figure something in that figure about 1.5 something. When they drawing the hyperbolic objects, they use negative A in their drawings to measure the distance. And you, as the first time, you might be bothered why they use negative A to indicate a distance, and that's the reason. Okay, and I didn't know why in the first time, and then I dig out the whole history, and basically that's the whole the ancient development history behind. And not many textbooks describe this kind of thing. They just directly jump into using minus A, and that one has been bothered many students before. Okay, so here I decide this year I dig out and then give you the note. So keep this in mind when we go to hyperbola. Then all the parameters will be intrinsically negative, so we have to put a negative sign to make the whole thing positive. Okay, okay, that's it, and that is the thing today. Thank you.